Hello everyone, welcome back to Data Programming 1. This is our second lecture. We're going to be focusing on the terminal today. Before we get started, I just have two announcements. The first, thank you for all the feedback, you guys. There was a number of comments about the length of the videos. Our goal over the course of the semester is to make sure that the videos are average about 50 minutes per lecture, and some of them will be longer, some of them will be shorter. Personally, I don't really feel that bad going over. I have a hard time guessing what questions you guys have while I'm sitting here at my desk recording these videos. So if I do an extra example or something, it doesn't really bother me that much. If it really is a problem for you, and send me some more feedback and let me know. And a lot of the things that I will be doing in the future will be extra examples at the end. But give me some feedback and let me know if they're useful or if I shouldn't do that. The other thing, I've gotten a number of questions about how do I go to office hours. So I just want to pull this up. This is our course schedule. We're right here. Later on, you're going to need to download this worksheet for the last third of the lecture. But how to get help, how to visit office hours. This is that link right up here, how can I find help? And it goes through all the different ways you can contact us. Lab hours are right here. That'll just jump down to what you can see right here. Lab hours are just an open time. You can show up or not, work on your lab. Think of it like giant group office hours in a way. Just a place to go and ask questions where there's going to be other people around. So there won't be any sharing of code. To use office hours, this will get you a one-on-one appointment with you and potentially your partner with one of the TAs. To do that, you use this office hour request tool right here. So you put in your name, I'm Mike. You need your Wisconsin email ID. What kind of question do you have? Then type in your question. And there's sub-project tabs here. If I click project, it's going to ask me which project, what question number, that kind of stuff. And then all I do is I click submit. All right. Once I've done that, I've got two more links here. I can go to the dashboard. That's also what this is right here. If I just click it, it'll take me to the dashboard. And this is going to show me all of the people who have put their name in the list ahead of me. After that, I can see that there are people having office hours right now. And when my turn comes up, whoever's doing office hours will grab my name, move me over to in progress, and then come find me. All right, so what I'm going to be doing is waiting for them to come in the Canvas Blackboard Collaborate office hour groups. All I do is I go here, and I'm going to hang out in the I get main room, general room, common room, I forget what it's called. And then when it's time, they will pull me into a breakout session. And you can see that right now, Akil is in breakout group 2. And so when it's my turn, he'll pull me in. All right, so that's enough of that. Let's go back to the terminal. How do I get there? PowerPoint slides. Yep, okay, the terminal. So for a lot of you guys, using the terminal might be a new way to interact with your computer. So we want to just spend a little time and make sure you guys become familiar with it. Let's take a little look at the history real quick. A long time ago, back when computers were first invented, they were very expensive. Most people would not have their own computer. In fact, a department like the computer science department might buy one computer, costing millions of dollars back during the 60s. And what they would do is they'd want to get as much use out of that computer as possible. So they would purchase these dumb text-based terminals to connect to the powerful mainframe. These guys are just little more than a screen and a keyboard and nothing else. You type something in, they send it to the mainframe where it does all the work. And then it sends back whatever wants to be put on the screen. Today, we have much, much faster, more powerful computers. And what we'll do is we still have the ability to use terminal-like features through a terminal emulator, like these ugly boxes right here. And the question is, why would I ever want to use a terminal emulator or a terminal? And the reason is a lot of times typing on the keyboard is faster than actually going and using the mouse. If you think about navigating your file system, if I know exactly where my file is, I can type the names of all the directories I need to move through much faster than I can click on a menu and then spot the right thing and click on it when I know what I'm looking for. Okay, so a couple of career tips here. The first one is that ask yourself, is this a good tool? Is using the terminal a good tool? Just because I don't know how to use it right now, and I'm way faster, using File Explorer or Finder and clicking things. But if I were to invest some time and get really good at it and get fast with it, would I be faster? Is it worth investing the time? And I think this is true for a lot of data programming tools, data science tools, computer programming tools. They can make writing code significantly faster when you're good at them and can be well worth the investment. The other thing, where's the other one? Yep, the other tool tip is find some tools that let you do this job from anywhere. For example, if there's a global pandemic and you're stuck at home, you still want to be able to do your job. The world is still going to need data scientists out there who are analyzing data, maybe potentially data about the genome of a vaccine or a virus, or producing a vaccine, or just counting number of cases of the virus. In fact, using a terminal emulator is going to let me connect to the computers at the university, and I can do my job from anywhere. Right now, I'm sitting in my basement. 3 weeks from now, I'm going to Las Vegas. You guys will never even know that I've left the house and that I'm actually sitting in a hotel doing my job. So when we start up a terminal emulator on our computer, I'm going to be using PowerShell on my computer because I'm a Windows user. Mina is going to be using, it's actually, her terminal emulator is called Terminal on her computer. She's a Mac user. So if you want the Mac version, she's got, her demo is done with the Mac, and it's her lecture 2, or the video number 2 for today. But anyway, once you open up your terminal emulator, inside that is another program called a shell. And shells are really great programs. They're basically just ask one question: what should I do? And you give it a command. Then it asks, what should I do again? And you give it another command. And then it just continues like that. And it really only does 2 things. It lets me navigate through the files and folders on my computer, and I can run programs. Some of those programs are, so I'm going to start using the word directories. I use folders all the time because I'm a Windows user and they look like little folders. All of the commands that we'll be typing in have the abbreviation, like change directory. It's going to be changing from one folder to another. They always use the word directory, so all the abbreviations have a D in them, or a dir, so directories. All right. We actually have lots of options when it comes to shells. I'm a Windows user. I'll be using PowerShell. CMD is another shell available for Windows. This one has basically its own set of commands that are a little different from everywhere else. Mac users and Linux users in general have the same commands, and PowerShell is the Windows version that adapts and uses those commands. So it's a little more friendly for Mac and Linux users. I'm only going to be discussing commands that are universal and available in PowerShell and on Mac and Linux. All right, for the Linux, the rest of these guys are available on Mac and Linux. The default version when you open up your Mac terminal is going to be Bash. It's short for the Bourne Again shell. It's based on the Bourne shell developed by Stephen Bourne back in like 1979, right there. And then people reworked it, and when you rework something, it became the Bourne Again shell. They all end in SH, and this was just kind of a cool name. So next up, talk a little bit about running programs from a shell. It's easy. You open up the terminal emulator. The shell is already there. You don't even think that there's 2 programs. It just looks like one, and I'll demo this in a little bit. But all you need to do is from the prompt. So this here is the prompt, this full part right here. This is telling me that this is the name of my user, and this is the name of the directory I'm in. And then I've got a $sign. That's the prompt. So I'm just going to click and type a command. This ls, it stands for list. It's going to be listing all the programs and directories in my current directory. So there they are. I got a bunch of stuff there. Yep. And let me just highlight some of these things. I've got the prompt. I typed in the name of the program that I want to run. It gave me some output, the name of all those directories and files, and then it gave me another prompt. So basically this prompt is asking, what should I do? What should I do next? And it's just going to continue forever. All right, so next up, a little bit about navigation. So navigation is going to be trying to find the files that we want, or a directory, and just looking around. Probably you're familiar with using either File Explorer where you'll double click on the folders and move around, or the Mac version. I love this. Switch to a Mac. All right, awesome. Sorry, I got distracted there for a second. So navigation is looking for files that we want. We're using File Explorer or Finder. We can do that in Windows or Mac. But with the shell, we're going to be navigating using commands. We'll type in a command, and the command runs a program that does something, like in this case, change the directory or make a new directory. I'll demo all those in the live demo in just a minute. So let's take a look at a little bit about where the files are really stored. So file, because we want it to stick around forever, we don't want it to be lost when we shut the computer off. We're going to write this on a hard drive, either one of these style hard drives, a mechanical hard disk, or an SSD. And on a Windows system, I'm talking about Windows first. We'll go through all the details, and then we'll talk about the differences between Windows and Mac. But each drive is going to be given its own letter. So I may start out with a C drive, and I might collect a lot of videos that I'm making for YouTube and fill this up. So I'm going to go buy another one. This will be my D drive. And then what I find is that I want my games to go faster. So I'm going to buy one of these high-end, super fast SSD drives. It's going to be E drive. Put all my games over there. All right, next up, I want to just talk about files a little bit. So every file has its own file name and a path that's associated with it. So if I take a look at like this file right here, readme.txt, is found on the C drive. Here's the file name. The complete name, including the path here and the file name, is the path name. C is the drive letter, and that txt is the extension. That's going to tell us what kind of file it is. And right here in red, the separator. Mac and Linux use forward slashes for their separators, and Windows uses backslash for their separators. This is going to be one of those key differences where your code runs well on your computer and you turn it in and we grade it and it completely fails and we give you a 0. It's that separator that's going to be a problem. And I will highlight that when we get to working with files and the operating system in the last third of the semester. It's not going to be a problem right away. So in the first lecture, we talked a little bit about input and output. A keyboard, mouse was our great input devices, the speakers, the monitor, output devices. Files can also be either input or output. So we may have a program right here in blue that generates some output, and we save that to a file, store that on the file system. And then later on, we run the program again. We may want this file back, and we'll open it up and put it back into our program as input. Directories on our computers can hold either files or other directories. And just like files, the way they have a path name, directories also have path names. So just as an example, here I've got 3 files, file 1, 2, and 3 in my directory. And that exists on the C drive. So the complete path for file 1 doc is going to be this entire thing. The path for the directory is just going to be the C drive. And all 3 of these files are in the same directory. If I add a couple more to the list, I can see that in directory 1, I have another directory. So directories can contain directories. And this one also has file 1. But because these are in different directories, I've just reused the name, but these are actually different files. This one has this path, and the other file 1 has this complete path. We have 2 different kinds of paths, 2 different ways we can refer to different files, relative and absolute. In this case, all 5 of these are absolute paths. They tell me exactly how to get there. Let me use maybe a simpler example. If I ask the question, where's the computer science building? All right, I know you guys, we're not in the computer science building right now. We're all sitting at home. Some of you guys are on the other side of the world, so just bear with me. This example works way better when we're in a lecture hall across the street from computer science building. But here's the idea. I've got 2 answers to this. I can tell you it's at 1210 West Dayton Street, Madison, Wisconsin, 53706. That's exactly the information you need to know where the computer science building is. Or, well, I could say on the other side of Johnson Street. Answer 1 pretty much always works. You can go plug that into your phone. You can look it up, see exactly where it is. Answer 2 really is only a good answer if we are across the street from the computer science building, and then I can tell you it's right there across the street. Now, this is oftentimes a lot more convenient. It makes a lot more sense to people if I am standing across the street from the computer science building and I give you this address and you have to get out your phone and plug it in, you're going to be like, I'm wasting your time. If you could have just said it's right there across the street. So the same thing will happen with path names. We'll see that we have both absolute and relative path names. The absolute paths are always possible. We had some examples on the previous slide right here. These are all absolute path names. And the relative paths are only really good if we already have some information. We need to know where we are. And that where we are is known as the working directory. It's our current location. So let's just take a look at some examples right here. All right, so what we're looking at here, in the middle is the working directory. So this is, if I open up File Explorer or Finder and looking at a particular directory, this is the one I'm looking at. Over here, I have the absolute path of a file. What I'd like to do is just go through some examples of finding the relative path from an absolute path in a working directory. So in this case, in the first example here, if I'm on the C drive and I'm looking for this path right here, the test.txt is already on the C drive. All I need to do is type in test.txt. So this one's very straightforward. The second one is very similar. If I'm in directory XYZ, I've navigated through Finder and found that particular spot, and I see that my file is in directory XYZ. All I need to do there is type my doc, and I'm good to go. If, however, I'm one level up in the directory tree, if I'm sitting at directory XY, and my file is actually at XYZ my doc, what I'm going to need to do is type Z my doc. Let me see if I can just bring this up. Yep, directory Z / my doc to get to that location. And we can do the same thing with directories. So if I'm actually trying to get to a directory, XYZ, and I'm sitting at a directory, a working directory will always be a directory. If I'm just in directory X and I want to get to YZ, I can just type Y/Z to get to there for the relative path. All right, a couple of other little things here. Special directory names. There's actually 3 of them. I've got 2 right here. The ... means move up one directory. So like if I'm sitting at directory XY here and I do ... that's going to move me up to just the X directory, which I get right there. And the dot means just the current directory. So here's a couple more examples. If I'm looking for test.txt, one of the things I can do, I can also refer to this as /text, test.txt. There's no reason I can't put this. It's not really necessary in a lot of cases. And I'll point out some examples where it is. I can also do / that says current directory. In the current directory, / again, test.txt. All right, great, that works. It also works with directories, so I can do / YZ. So that's just this example one more time with the / in front of it. Also works for directories. And then let me just talk about this example a little bit real quick. If I'm in a directory XYZ, I'm 3 levels deep into the tree of directories, and I want to get to this absolute path. That means I need to move up. So ... basically is going to remove the Z here. So I'm going to move up 1 level, and then I'll be in Y. I'll need to do that again. So I'll add another ... and that will move, where's my mouse? Up out of the Y into the Z. Whoops, X, that's the letter X, directory. So it should look like ... /. All right, one more example here. In this case, I'm looking at a working directory of C drive A directory. And what I really want to get to is in the B directory, file.txt. So give this a thought for a second. Pause the video, jot down what you think the relative path will be, and then come back and I'll tell you the answer. All right, welcome back. So here's what we're looking at. What we need to do is we need to get out of the A directory, move up so that we're at the top level, the C drive. To do that, I'm going to do ... Okay, now I'm going to be at C. From there, I need to move into this B directory. So I'm going to do B, and then another /, and then file.txt to get to the file. All right, let me do a couple of picture versions. So right now, this is my current working directory here. I'm in the A folder, A directory on the C drive. So C drive has 2 folders, A and B. This is my current working directory. What I need to do is first use the ... to move up to this C drive. From there, I'm going to use B to move over into the B directory. And from there, file.txt gets me into the file that I care about. And we'll do a couple more examples of this kind of stuff in the demonstration in a little bit. All right, I want to just discuss a little bit of the few differences between Windows and Macintosh computers as far as like the drives go. On Windows, all of the absolute paths are going to start with the name of a drive. That's C:\\, or like D:\\. It tells us which drive our data is stored on. However, on a Mac, first the separator is always going to be the /, and absolute paths always begin with that /. Here's an example, /users, Tyler, my file doc. It never tells us which drive we're actually storing this file on. So how can we have multiple drives if every file path starts with the same symbol? We really can't tell what drive it is, not by just looking at the absolute path. It basically, all the different drives just feel like different directories. And in fact, if I'm looking at some different files, if on a Windows system, if I've got file.txt in users Tyler, on a Mac, it's going to just have the /. There's going to be no drive letter. So users Tyler file. Program files here is a directory on C drive here. Here that's equivalent to the user's local bin. If I'm looking at the D drive on Windows, this might be volumes backup A. And in fact, the E drive could also have volumes movies. So these drives could have, basically it's designed to look the same. So think about it like this way. Suppose I've got my hard drive and it fills up with movies. And then I have more movies, so I buy another hard drive. I don't want it to look like I've got lots of drives. It's going to be all kind of, what's the word I'm looking for? Hidden from me. On a Mac, the path doesn't tell me what drive I'm on. They all just look like directories. So I can move my movies around. I can move them to this new hard drive that I just bought, and it still feels like they're in the same place as far as like how I need to, write to find them, how I want to navigate to that directory. All right, I want to just walk through a couple of simple examples in the slides. So when you guys pull up the PDF of the slides and are walking through this, you've got some examples. And the ones I'm going to talk about here in this slide, they're all based on the Mac computers. You can see the /. And then I'm going to do my demonstration with the Windows machine and highlight some of the differences there. I'm going to focus only on commands that work on both Mac, Linux, and Windows in PowerShell. So the first command I want to talk about is pwd. This is going to tell me where I am. It stands for print working directory. So when I run this, it's going to just print out exactly where I am. Now check out my prompt right here. ps/users trh scratch. This prompt already contains the name of the directory. That's pretty common. PowerShell does that by default. The bash prompt on the CSL machines does not, so pwd can be very valuable. I'm personally not a fan of having the directory in the prompt. It takes up a lot of space, makes it hard to see what you're typing if you're really deeply embedded in your machine, in your file directory. And there are ways to change that, and I'm not going to actually go into that for this class. Okay, next up, so it's printed out the current directory right here. Next, if I want to make a change, right now I'm in the scratch directory, cd ... will move back up one level. And now my current path is users trh. From here, if I want to clear the screen, it's getting kind of full, I can use the clear command. And now I'm back up. Beautiful, clean, black screen with just a prompt. So from there, I can move back into the name of the directory using cd, it's short for change directory, and I just need to type the name of the directory that I want to go to. This one happens to be where I just was, so cd scratch. And now I'm back there, exactly in my starting position. The cd/ command will take me to the root directory, so just the very topmost level, and this angle bracket is the prompt. All right. ls is going to list the contents of the current directory. So when I type ls, it's a program, and it's just going to go through and print out all of the contents of the root directory in this case, the topmost level. Another command that we're going to find to be really useful is the cat command. Cat takes one argument, readme.txt in this case, it's the name of a file, and all it's going to do is print out the contents of that file right here. So if I click go, this file says hello, and that's what the contents of readme.txt are. the data saved. Yep, there we go. Arguments. So some commands, like cat here, require an argument. This is input to the program. Cat is the name of the program. It needs to know which file do you want me to read. So that's known as an argument. All right. Echo is another, well, in a lot of ways. Here, let me just give you a demonstration. If I type echo, it takes an argument. In this case, I'm giving it the word hello. All it does is print out hello. That's all it does. It's just going to take whatever is on this line and print it out for us, which is not super useful. But it turns out that it's a great way, prints out whatever the argument is. It's a great way to create new files because the right angle bracket is the redirection operator, and that's going to send output to a file. So if I type echo hello, use the angle bracket, give it the name of a file, it's going to create this file, and it's going to store the word hello in that file. So from then, this first case, it was printed on the screen. Note that it's not printed on the screen here. It just gave me a prompt because it actually redirected the output to output.txt instead of printing it on the screen. And then when I read output.txt, cat is again the command that I'm going to use to read files. So cat output.txt, and there we go, hello. All right, next, I'd just like to open up PowerShell and go through demonstrating some of these things for you. If you're trying to follow along and do this on a Mac, to get to the terminal, you're going to go to Finder, then Applications, then Utilities, and Terminal. Mina's demo, lecture 2 under today actually is her demo. She's done it as a separate video. If you have a Mac and you want to follow along with the Mac version, I recommend you just jump over, watch her video too, and then come back. And you're welcome to stick around and watch mine. You might learn something else. I'm not sure entirely what she's done. All right, so I'm going to get out of this. To get to PowerShell, I'm just going to click on the Windows Start button. I can't spell UW power. There we go. Type the word power, and that's enough to get to the Windows PowerShell. This is the one I want right up here, without any of these extra letters at the end of it. The short one, simplest one. All right. When I click that, it opens up PowerShell. I can see that it's telling me I'm in PowerShell. The PS here stands for PowerShell, and it's giving me this prompt. That angle bracket there is the end of the prompt. And this particular prompt with PowerShell tells me what my working directory is. So, in fact, the command to get the working directory, and we're only going to worry about like maybe 8 commands today, but pwd is the one that tells me what my current path is. So this is my current working directory. And then it gives me another prompt right here. Okay. To get help, the command is man, and let's just get some help on pwd. So man is short for manual, like instruction manual, and I can type the name of any command following that, and that'll give me some help. If I read this, some of these can be really complicated, but they usually have this same structure. So what it's telling me is the name of this command has some aliases. GL for get location. I can actually type get location on this machine. And that will also do the same thing as pwd. Let's just go ahead and do that now. Get location. All right, there we're good. So multiple commands that do the same thing are known as aliases. All right, next up, let's do one more. And let's see. We had CD was one of the other ones we talked about. So also known as set location. We've got some other aliases. It tells us the optional parameters that we can put in. I just want to point out here that this man is a program that I'm running. Right now, all it does is display information. It's got this more here. I can click enter to get and finish the program. If I go back and do this one more time, I can also type Control-C to kill the current program. We'll find that to be really useful when we write programs that have loops that just don't end. All right, I want to just take a moment and talk about efficiency. So a moment ago, I was describing how it can be more efficient to use the keyboard to navigate your file structure than it is to click through. Let's take a look at this. So this particular, my home directory has a ton of stuff in it. All that stuff is there. If I want to get to my teaching materials, all I need to do is type let me see how many letters did I really need. T and then tab. So tab completion will let me move into, basically finish the word for me. I don't have to type all those letters. So I moved into teaching, and then I've got all these classes here. Let's check out, how about CS 368 C++. In here, I've got a bunch of stuff too. So CD, CS. So I tap tab, and it's going to give me the first option that matches. Tab again will move down and give me the second option. Let's see what else we got here. CD homework. CD, I believe I have homework 1. And that's as deep as it gets. Okay, now this is one of the reasons I dislike PowerShell's, the way it puts in all the files. Because when I'm working on my classes, I've got all these directories. Everything is sorted very neatly. Otherwise, I lose track of stuff. But it takes up like more than half of the screen. All right, I got to fix that. I'll do that later though. All right, so next up, I mentioned that there were 3 special commands. CD ... moved me back up 1 level. CD ... is the current directory, and CD tilde is the third one. That's going to take me back to my home directory. My home directory was at C users mic. So CD tilde gets me back there. It doesn't matter where I am. I could go all the way up and be looking at the C drive, and CD tilde will take me back to there. All right, another way that we can use the terminal very efficiently is with the up arrow. If I've already entered a command, I can just use the up arrow to go back and look through the commands I've already used. So here I can do CD teaching. I can do about get location. Okay, so that's just one more way that I can save myself some typing. I have a lot of students that come to office hours, and I watch them type things where they could use tab completion, where they're typing the same command again that they just did, particularly if they're trying to like compile some C code or something that can be a long command with lots of little options that they need to get just right. The up arrow saves tons of time. So these are those little tricks. Learn the keyboard shortcuts for the software you use, whether it's Microsoft Word or whether it's high-end programming software. Learn how to use it. All right, next up, the history command. This is going to give me the list of all of the things I've typed in recently. And then once I've got this, I can use Control R to do a search for things. And this is going to search from the bottom of this list, starts at number 30 and moves back higher in the list. And all I need to do is start typing something. So G gets me get location. Looks like I've done that a bunch of times. I'm going to delete that. Let's go with M. So the most recent thing that has an M in it is homework. If I do MA, the most recent thing that has MA in it, it looks like right there on line 12, man CD. And I can just push enter now, and it'll run that command again. Control C to kill that. All right, so that's the history, the, what is it called? I think it just told me that. The backward search. All right, so next up, let's get out of here. How about running other programs, things we might be familiar with? Like Notepad is something I use all the time. If I just type Notepad, it opens it up. I can read my files from here. Close that for a second. What about Chrome? I use my web browser all the time. But when I do this, I know Chrome is on the computer, but it's not recognized. It turns out that this isn't on one of the places where PowerShell is going to look for programs. It's not on the right path. So what I would like to do right now is walk you guys through how to add Chrome to your path, to the system path, so that you can just type Chrome from the terminal and it'll work. This is for PowerShell only, it's for Windows only. The Mac version is different. If you want to add this to your computer using a Mac, go watch Mina's video. It's her second video. Okay, so here's the idea. I want to add Chrome to my path. So then I can just type Chrome from the terminal and get it. So to start out with, I'm going to go and just look up Chrome. Here it is right here. I'm going to, I click the window button, I typed Chrome. I'm going to right click on this. And then right there, the second option is open file location. So I'm going to click that. All right, there's actually 2 steps. This first one can be a little deceptive. I'm actually looking at the start menu programs. So these are just all the things that are in the start menu. This is actually not the program, it's a shortcut to the program. But that's perfect because the shortcut knows where it's located. So I'm going to click on that. That's a right click. Then I'm going to click Properties. And one of these things here is going to be the target. So this target, I'm going to copy that. Looks like it's actually quite long. And now we should be able to go to that directory. So I'm going to go back over to PowerShell. Let's just take a look at this. So I want a CD. I'm going to right click because in PowerShell, right click is both copy and paste. Very convenient. It's already in quotes. I don't want a CD with this chrome.exe. I want to just CD into a directory. So I'm going to delete some of this. There we go. Now this should take me to the right directory. ls. There it is right there. It's the third one down, Chrome. Okay, so great. So I can type Chrome, and it still gives me an error. It's not recognized. So part of the problem is I'm going to need to add the path to this file right here because of the way the directory is organized. It's not recognizing it. Okay, so here's the idea. I'm going to go to Windows again. I'm going to look for path. That's where I need to add it. And over here, edit the system environment variables related path. This is the one that I want. Edit the system variables. So I'm going to click that, and I hope this is big enough for you guys to see. It's an environmental variable, the path. I'm just going to click right there, and then I can see I've got local variables for me as a user, Mike, and system variables that are for everyone. I'm just going to go here and just edit it for me. So I click path, I'm going to click edit, and then what I see here are all the different paths. So when I type a command like Chrome or Notepad, it searches all of these directories to see if that program is there. I'm just going to go down to the bottom right here. I'm going to add a new path. I'm going to paste in the path to Chrome. I don't want the chrome.exe. I just want that directory. So now it knows to look in that directory. And let's see, OK, OK, OK. And now I'm going to need to start a new instance of PowerShell. Let's see here. I've got it on my hotbar right there. And now I should be able to type Chrome. And it opened on the other window. That's awesome. Let me try it this way. Let's see if the last instance of Chrome is right here. And it'll pop up on the other window monitor. All right. Trust me, it totally worked. Hold on. Wait, one more try. Okay, I had a couple of instances of Chrome open, and they were all on the other monitor. So it was trying to open them on the other monitor. But check this out. R-O-M-E, Chrome, enter. Voila, it's totally working. All right. Let's try one more thing. I can also put the name of a website that I want to go to. So I can type Chrome. Let's try that. A puppy. That's cute, though. All right. For a moment there, I was like, my heart was racing a little bit, thinking, what if something comes up and it's not good? Can't put that on YouTube. All right. All right. Next up, I just want to do a little bit more with changing directories, including creating a new directory and then using that echo command to create some files and copying and moving them and reading them with cat. So that's going to wrap up this part. Let me just demo that real quick. First, I'm going to move over to the desktop, and then I'm going to shrink this a little bit so you guys can see what's going on. I've just navigated to the desktop. If I do echo and I type in a word, this is just going to print it to the console right there, to the screen. If I do the angle bracket, this will let me write it into a file, and that should appear on my desktop right there. Let's see here. Let's do hi.text. So when I write that, let's see, where did it go? Yep, there it is, down at the bottom left. It's tiny. Hi.text. All right. I can also create a directory. So I can do make dir. Let's call it my dir. It tells me I've just created a directory, and there it is up there, right at the top. Then let's go ahead and copy. So we'll make a copy with cp hi.text, and we'll move it into my dir. And then I need to give it a name. We'll go hello.txt. Okay, so copy takes two arguments. The first is the file I wish to copy, and the second is the destination where I want to copy it to. So check it out. Hi stays right here. If I open up my dir, what I see is there it is, hello.txt. If I click on this, Notepad will open it up, and it does indeed say hello. I should have done that over here when I created it. When I open up hi.txt, that also says hello. All right, check this out. If I do, let's go, I'll go world to hi.txt, and I go back over here. Check it out. It no longer says hello. It just says world. I basically destroyed the contents of that file. So let's do a little bit different version of that. The double angle bracket will append to the end of this. It won't just nuke the old file and start over. So now, if I do this, it says world peace. Let's see, what else? Oh, yeah, cat. Cat is the command that reads out files. So I can give it cat hi.txt. And that's just going to print out the contents of that file. Looks like my screen is getting full. We'll clear that. Let's see, what else? Oh, I didn't talk about move yet. So if I want to move a file, that's going to let me take it from one place to another, or it can let me rename things. So let me just demonstrate that. If I have hi.txt as my source, and I want to rename that to howdy, well, we just change it to say world peace. Let's go with, we'll call this Christmas list.txt. What do you guys want for Christmas? And then it's changed the name down here. I can see that. If I double click that, I can open up, still says world peace, and now it's, I can see right there the name of the file has changed. All right, I feel like this video is getting kind of long, but I want to just have a little bit of fun right here at the end. So first thing I'm going to do, I'm going to create a file. Win, I'm going to stick that in A. Lose, stick that in B. And now pay very careful attention. I'm going to move B to C. I'm going to move A to B. And now I'm going to move C to A. And then I'm going to cat A. Pause the video. Tell me what's going to happen. Make a guess. Write it down. Commit. And then come back. All right, I'm here with the answer. I'm going to push enter. And we'll see what comes out. Ooh, A was losing. So here's what happened. We got to keep very careful track of this in order to figure out what's going on. So win was stored in A, lose in B. And then B was moved to C. So B is gone. We've renamed it. It's now C. So I've got two files, A and C. And A is the one that's got win in it. Then we moved A to B. A was gone. B is created. I now have two files. They're B and C. And B is the one that says win. Then I moved C to A. When I use move, it's going to get rid of C. That's gone. And I have A. And I've got two files now. They're B and A is the one that says lose, and B is the one that says win. All right, so I hope that made sense. I hope that was a little bit of fun. And I'm going to go grab the worksheet that goes along with the final part of this, and I'll be right back. So for the final part of this, I'm just going to be going through some of these questions on the worksheet. So go to the web page, click the worksheet, pull this up, and maybe even print it out or get some scratch paper so you can work through this alongside with me. So this worksheet has a bunch of questions on them, and we're only going to look at 4 of them. The idea here is that we're going to pretend we're computers, and we're going to be going through and following these directions and just going through the process. The idea here is we're going to learn about control flow, which I mentioned briefly in my first lecture. Control flow is the first 5 weeks of the class. Data was the second 5 weeks. And then special topics, data programming was the final third of the class. So control flow is all about what is the computer doing right now? What is it doing next? What is it doing next? So that's what we're going to be doing, is just going through some of these instructions. So I'd like you guys to just go ahead and do this. Just take a look at this problem and walk through the code. Pause the video and I'll be right back and I'll go through it myself and then we can talk about it. So pause now. All right, welcome back, guys. Hopefully you got a chance to do that. So what I'd like to, whoops, that's not right. That's not right. There we go. Got a mouse in the right spot. So as we go through this, first I've got my X box there. The first line says add 1 to the X box, and then the box should look like strike through 10, 11. Because of the way I'm using PowerPoint to do this, is that easy to do? Where's strike through? Nope. I'm going to go with delete and write 1. There's an 11. Okay. Sorry, I'm not following the directions exactly because I'm not using a pen and paper. Hopefully this still makes sense. Next, I'm going to add 2 to the X box. All right, so it says 11. I add 2 to that. I'm going to get 13. And then finally, I'm going to double the value in the X box. So 13 times 2 is 26. All right, there we go. Final answer. 26. Now, the question here is asking, what if my friend got a different answer, 24? They're a troublemaker, and they don't like doing things in the right order. The question is, what's a good rule to make sure that everybody gets the same answer? If we have a set of, if everybody in the classroom brings a laptop and they do the same, give the same code to them, they should all get the same answer. So the idea here is this is the first part of control flow. And that's we're going to do the steps sequentially in order, one at a time. And we're going to execute each step exactly once. So we'll do step 1, then we do step 2, then we do step 3. We're not going to mix up the order. We're not going to do things more than once. We're not going to skip anything. So that's rule number 1 for control flow. Forgot I made a slide for this. Sequential execution, first rule. All right, let me pull up that second example. Next, we're going to be doing problem 4. All right, guys, I got the example set up here for us. Go ahead, pause the video, take a moment, walk through these steps, and then after you come up with your answer, go ahead, come back and push play again. All right, welcome back. So let me just walk through this. Step 1, if the value in x, there it is, x is negative, continue to step 2. Otherwise, skip to step 3. Okay, it is negative, so multiply the value in x by -1 and put the result back in x. So let's go over here. Let me grab the right spot. I need to multiply by -1, and that makes this positive 4. Excellent. Then I'm going to continue on because my first rule of execution says, first rule of control flow says sequential execution. So now I'm going to do step 3. It says copy the value of x into the ABS box. So I've got a 0 there right now. It needs to say 4. What is this function really doing? It's computing the absolute value of a number. If x had been positive 4 when we began, just like it is right now, positive 4, let's walk through this again. If the value in x is negative, continue to step 2. All right, it's not negative, otherwise skip to step 3. So we're going to jump down and do step 3 now. And we just directly copy the value of x into the ABS box. And it's already there. So here's the idea. The second rule of control flow is a technique we can use to skip things. In this case, this is known as a conditional statement. And the key word here is if. So these are going to be known as if statements or conditional statements. So that's our second piece of control flow. All right, for the next example, I'd like to do problem 6. So go ahead, pause the video, walk through this yourself, and then come back for the answer. All right, I'm just going to walk through this. So put 1 in the total box. Let me click over here. I'm going to put a 1 in there. If n equals 1, it does not, it's 4. If n equals 1, skip. Otherwise, continue to step 3. So I want to do step 3. Multiply the value in total by the value in n. Put the result back in total. So total is 1, n is 4. I want to multiply those together and put the 4 back in total. Just like that. All right, then I want to decrease the value in n by 1. So right up here, it goes from 4 to 3. And then I'm going to go to step 2. All right, great. So I'm back at step 2. If n is equal to 1, it's not, it's 3. So I don't skip to step 6. Otherwise, I'm going to continue to step 3. Multiply the value in total by the value in n, and put the result back in total. So that looks like 3 times 4, which is 12. All right, next up. Next rule says we're going to do sequential execution. So we go to step 4. Decrease the value in n by 1. So 3 becomes 2, and go to step 2. Step 2 says if n equals 1, skip to step 6. It does not. Otherwise, go to step 3. Step 3, multiply the value in total by the value in n. Put the result back in total. So 2 times 12 is 24. Then I'm going to go back and decrease the value in n by 1. Go to step 2. If n equals 1, haha, it does. Skip to step 6. I don't even need to read the rest of that. I just got to go to step 6. Copy the value in total into the answer box. Okay, great. Everything looks good here. Looks like this function, or this little piece of code here is actually computing the factorial. So 4 factorial is 24. 4 times 3 times 2 times 1. So what we've just seen here is an example of iteration. As we went through the code, we did step 2, 3, 4, 5, 2, 3, 4, 5, 2, 3, 4, 5, and 2, 6. Well, so we did those steps over and over and over again, and in a loop. So the next piece of, there we go, control flow is this idea of iteration or looping, where we're going to do a bunch of steps over and over. So again, control flow was walking through what is the code doing right now. If it's in a loop, it's going to go through and execute that sequence of steps multiple times. All right, to wrap up one more, go ahead and take a look at this example. Go ahead and do this on your own, and then come right back. All right, welcome back, guys. So I'm only going to do part of this. This is getting to be a really long video, but let me at least get started here. Main code. Put 2 in the moves box. There we go. Now we're going to perform the steps under move code, then continue to step 3. All right, so we jump down over here to move code. If moves is 0, it's not. Stop performing these steps in move code and go back to where you were last in main to complete more steps. Okay, it's not. So we're going to continue with step B. Move the robot forward 1 square in the direction the arrow is pointing. This is the robot right here. It's the one that has the arrow. 1 second, let me go ahead and do that. All right, I've got the robot moved. Next up, it says in step 3 there, decrease the value in moves by 1. There we go. Then we're going to go back to step A. Aha, this looks like iteration. We just talked about that. So if moves is 0, stop before. Okay, it's not 0. So step B, move the robot forward by 1 square in the direction the arrow is pointing. So grab the robot, move him up. There we go, that looks pretty good. Then we're going to decrease the value in moves by 1. All right, go back to step A. If moves is 0, stop performing and go back to where we came from. That was up here in line 2. Perform the steps under move code, then continue to step 3. All right, next up, rotate the robot by 90 degrees to the right. Let me see if I can do that easily. There we go, that looks pretty good. All right, then we'll put 3 moves in the move box. So 3. And now as we go through, it says perform the steps under move code, then continue to step 6. So I go down, move code. If moves is 0, it's not. Move the robot forward 1 square, the direction the arrow is pointing. There, that looks pretty good. Decrease move code by 1, so now it's going to say 2. All right, I hope you guys can see that it's going to take 1 more step forward and then 1 more step forward after that. Moves will go from 2 to 1 to 0. Let's just fast forward this. We'll drive the robot over there, and it ends up on the heart. All right, excellent. So here's the idea. This next piece of control flow is known as functions. So what I've done here is I've taken a bunch of steps and I've pulled them out from the main code. I could have easily just said in step 2 right here, just copied and pasted all 4 of these lines right there. And then in step 5 where it says go to move code, I could have put these 4 lines right there, but then I would have had those same lines twice. And if I needed to make a change, I would have made 2 changes in order to get this to work. So this is the idea where I'm going to just step out of my sequential execution, go do some stuff, and then come back. And it lets me sort of extract pieces that do the same thing over and over again, pieces that I need. So that's the idea of function calls. And finally, to wrap up, let me click on this and put in all 4 pieces of control flow that we'll be talking about and how to do them in Python over the next 4.5 weeks. All right, this is going to do it for me. Go ahead, do the rest of the problems on that worksheet, walk through, get some practice thinking like a computer. If you have any questions, bring them to our live Q&A or to office hours. And have a great day, everyone.